Welcome to the course Electronic Circuits 1, Unit 4. Today topic is Miller theorem and low frequency response of MOSFET amplifier. Okay, so whenever if the element is there, okay, if the element is common between both input and output, then what is this effect of this element on input as well as at the output that is given by the Miller theorem. Okay, if I have some impedance that is common to both input and output, then I can map this impedance into input impedance, input side as Zi, at the output side as Z0. Okay, so finally my Zi is going to depend on Z as well as some parameter of the circuit. Okay, because I have not shown the circuit here, but actually there will be some circuit will be there, small signal model. Okay, small signal pi model will be there. Okay, so and again this Zi depends on Z as well as the gain of the circuit that is present here. And again similarly Z0 also depends on Z and gain of the circuit in some other way. Okay, so and again Zi is equal to Z divided by 1 minus A, where A means gain of the circuit. Z0 is equal to Z divided by 1 minus 1 by A. If A value is very large, and again Z0 is simply is equal to Z. Okay, now again what is the voltage gain. Okay, the voltage gain of a BJT is equal to minus GM RC parallel with RL, or otherwise GM, the transconductance can be replaced by HFE divided by HIE. Okay, then this is the small signal model. Okay, so Is is the source current, and as it is a current source, then there will be the resistance in parallel. Okay, biasing resistance RB, and then R pi is the small signal equivalent resistance R pi at the input side. C pi is the capacitance at the input side, and C mu is the common capacitance between the input and output. GM V pi is the uh, voltage dependent current source. Okay, GM V pi is the GM and V pi is the voltage dependent current source. RC is the collector resistance, RL is the load resistance, and C mu is the capacitance common between the input and output. Now this C mu is mapped as CM here. Okay, and again rest of the circuits are same. And once if it is mapped, then the input capacitance is not C pi, it is C pi plus CM, because when the capacitors are in parallel, then you can simply add. Okay, now what is the effect of this? Okay, so in general the 3 dB cutoff frequency is 1 by 2 pi RB parallel R pi, because only R pi will be there, but here RB also is there, so that's why RB parallel R pi. Then in general C pi will be there, but here CM is also there. Then the new capacitance is C pi plus CM. Okay, now what is the input impedance? Okay, then input impedance, okay, is equal to okay, the input impedance due to the Miller capacitance. That means impedance of the Miller capacitance. Okay, then that is Z divided by 1 minus A. Okay, Z means that impedance of the C mu. Okay, that is 1 by J omega C mu divided by 1 plus mod AV, because A value is negative, finally this will be 1 plus. Okay, that's why 1 plus. Okay, and mod value of AV, and again this term comes down, and again in product with 1 plus mod AV, and this C mu 1 plus mod AV, I can write it as CM, because I mentioned here as ZM is equal to 1 by J omega CM. Then from this CM is equal to C mu 1 plus mod AV. Okay, and again what is AV. Mod AV is equal to GM RC parallel RL. Okay, now if the gain increases, okay, if the gain increases, okay, if AV increases, what will happen that and again the Miller capacitance, sorry, if the gain decreases, okay, if the gain AV decreases, then the Miller capacitance will decrease. But if the Miller capacitance decreases, what will happen? 3 dB cutoff frequency will increase. 3 dB cutoff frequency means bandwidth. Okay, so finally the bandwidth will increase. Okay, so now we have seen the effect of the Miller capacitance. Okay, because it is mapped at the input side, then based on the gain, it value may vary, and again it varies the cutoff frequency, and finally it varies the bandwidth of the amplifier. Next, low frequency response of MOSFET amplifier in the common source mode. Okay, so again this is something similar to the low frequency response of BJT amplifier in common emitter mode, except that BJT here we have replaced it with a MOSFET transistor. Okay, and again voltage source, source resistance, coupling capacitance CC1, biasing resistance RG, then RS is a source resistance, and then source capacitance, this is the drain resistance, and CC2 is the output coupling capacitor, then RL is the load resistance. Now what is the effect of input coupling capacitor? Now what is the effect of the input coupling capacitor? Okay, that means here, okay, once if you see it from this, and then and again if you remove the effect of the voltage source that is short circuited, then RS and RG comes in series, okay, then again CC1, okay, and so cutoff frequency due to CC1 is equal to 1 by 2 pi RS plus RG into CC1. Next, what is the effect of the output coupling capacitor CC2? Okay, once if you remove this, okay, and again you remove the effect of DC, okay, then VDD here this terminal becomes grounded, okay, and again RD is there, and one more small RD will be there, because in the small signal equivalent one more drain resistance, small signal drain resistance will be there. Then this RD, that small RD comes in parallel, and again that comes in series with the RL, so 2 pi RD parallel RD plus RL into CC2. Okay, then what is the effect of this coupling capacitance? What is the effect of this coupling capacitance? Okay, so FL CS is equal to 2 pi R equivalent CS, because once if you remove this CS, then what is the resistance looking from this terminal? Okay, that we call it as a R equivalent. Then this R equivalent already we have measured it for BJT. So in the same manner we have to write here also. That depends on RS divided by 1 plus RS 1 plus GMRD divided by R naught plus RD parallel RL. If R naught value is infinite, okay, then R equivalent is simply RS in parallel with a 1 by GM. Okay, once if you know the actual values of this one, like what is R equivalent, what is CS, okay, what is capital RD, what is small RD, what is GM. Okay, if you know all the values, then you can find out the numerical values of this one. So already we have seen it, okay, even in the BJT also, the BJT itself we have seen. This is the lowest cutoff frequencies due to the CC1, the medium one is due to CC2, then higher cutoff frequency in the lower region is due to CS, okay, that bypass capacitance. Okay, and again this cutoff frequency due to the bypass capacitance is matching with the 3 dB cutoff frequency. Okay, so that's why and again, so this is again this capacitance decide the 3 dB cutoff frequency of the amplifier. Okay, and again this is the gain axis, this is the frequency axis. Okay, thank you.